Magnetism. Magnets. You know, magnets stick to some things, like laboratory doors. Pretty nice decorations, huh? Magnetism is invisible. And magnetism comes from minerals found in the Earth. And the Earth is so full of these minerals that the Earth itself is a giant magnet. That's what makes compasses point north. A compass is just a magnet that's free to move. Now, the most common mineral that can be made into a magnet is iron. Right here is some iron powder, and this is a magnet. Watch. The magnet makes the iron powder form these lines, and we call that a magnetic field. Now, only 3 things can stick to a magnet: iron, nickel, and cobalt. Nothing else will stick. Not rubber dinosaurs, aluminum, silver or copper coins, gold jewelry, but iron sticks great. Now, magnetism comes from moving electrons. You know what we call moving electrons?
No.
Call it electricity. Now, where would we get some electricity? Well, how about from this battery? Now, when I connect this battery, electricity will flow through this coil, and we'll get magnetism. Here we go. Watch. There's enough magnetism to hold up all this weight. Now, what'll happen when we disconnect the wire? Well, the magnetism will stop. You ready?
Sure.
3,
1,000.
2,
1,000.
1.
1,000.
Magnetism's pretty cool.
You live on a magnet. That's right, the Earth is a big magnet. That's what makes a compass work, even way up here. Now, where does the Earth's magnetic field come from? I mean, where are the moving electrons? Well, the Earth is full of melted iron and nickel, and the spin of the Earth makes the electrons flow in huge loops. The Earth's magnetic field extends way out into space. It goes right through the air and water. Spawning fish, migrating birds, and helicopter pilots all use it to find their way anywhere on the Earth. The Earth is a big magnet, and its magnetic field is pretty handy.
Now, on a piece of iron like this, the electrons are spinning all different directions. But in a magnet that's made of iron, the electrons are all lined up, so that a magnet has a front end and a back end, a north pole and a south pole. Now, what would happen if you could cut a magnet in half? Would you get a magnet that was only a north pole or a magnet that was only a south pole? Well, take a look at this. These are the electron cars of science, and they each have a front end and a back end, a north end and a south end. Now, right now, they're parked all which way, but let's line them up like the electrons in a magnet.
Back it up, Joe. Okay, Sally.
There. Now, let's cut them in half. See, we end up with 2 smaller magnets. These cars have a north end and a south end, a north pole and a south pole. So if you break a magnet in half, you get 2 smaller magnets that each have a north pole and a south pole. Near as we can tell, there's no way to get a magnet with just 1 pole. Now remember, magnets are made of iron, nickel, or cobalt. And the Earth is a giant magnet because its core is mostly iron and nickel. You'll find magnets in all sorts of things that you wouldn't expect. Like doorbells, electric can openers, telephones, stereo speakers, and videotapes, bank cards, refrigerator magnets, and audio cassettes. Very tall metal towers, such as the Eiffel Tower in Paris and the Space Needle in Seattle, are made of steel, which is mostly iron. So a compass needle points right to it. So if you're standing next to it, you could tell. You probably figured it out on your own, though, huh? You know, this is the same compass that Compass Man uses.
Magnetic or not? A screwdriver. Magnetic or not? Cold hard cash. Magnetic or not? A levitating train. Magnetic or not? This has been another Magnetic or Not.
Hello. Why does this do this? Well, they're magnets, right? And right now, the same side of each magnet is facing each other, so they push apart. We say they repel. Now, you may have heard that opposites attract.
Opposites attract. Opposites attract. Positive, negative, boom. There it is right there, simple. Opposites attract.
Well, it's true. Watch. See that? They pull together. They attract. These magnets are made of iron, and iron is full of electrons, tiny particles that spin around the outside of atoms. Now, when electrons are moving, we call that electricity. So watch. When I close this switch, electricity starts flowing through this wire. And look, the needles of these compasses line up in a circle. Whenever electricity is flowing, a magnetic field forms. So, here are the magnets, but where's the electricity? Well, let's say that this is a microscopic view of iron, and the electrons are spinning around in little areas called domains. Now, normally, the domains are pointing all different directions. The electrons are spinning all which way. But when iron is magnetized, the domains line up. And it's the lined up domains, the lined up little currents of electricity that make iron, nickel, or cobalt a magnet. Our planet, the Earth, is full of iron and nickel, and the Earth is spinning. The iron and nickel is so hot, it's always churning and burning. It's moving, so its electrons are moving. The moving electrons make a magnetic field. The Earth is like a giant magnet, and that magnetism is the same thing that makes compasses point north. The magnetism is looping through our bodies our whole lives. In fact, it's going through you right now. Isn't that wild? Well, thank you for joining me on Consider the Following. The Earth's magnetic field extends way out into space. Charged particles from the sun, called solar wind, hit the Earth's atmosphere, and the Earth's magnetic field makes the air glow. Now, where the Earth's magnetic field is the strongest is at the poles, so that's where the air glows the most. Up here, we call the glowing the Northern Lights, or Aurora Borealis. Down here, we call the glowing the Southern Lights, or Aurora Australis. Anyway, we end up with these big belts of charged particles held in space by the Earth's magnetic field. They're called the Van Allen belts, named after the United States physicist who discovered them. Sun's magnetic field causes sunspots, and they can make your television picture go fuzzy sometimes. I got some more news for you. If you're on Venus, Mars, or the Moon, you won't be needing this compass. You know why? They don't have magnetic fields, because their cores don't have enough molten liquid metal, and they don't spin fast enough to cause the churning and burning that you need to have a planetary magnetic field. But on Mercury, Jupiter, Saturn, Uranus, and Neptune, there are magnetic fields. On Jupiter, the magnetic field is 20,000 times stronger than the Earth's. On Saturn...
This is Magnetic or Not? An aluminum bicycle. Magnetic or not? More cold hard cash. Magnetic or not? The planet Jupiter. Magnetic or not? This has been another Magnetic or Not.